Okay, you're welcome back. We are asked to solve this problem. Y is equals to sine in bracket m arc sine x. Say show that now we show that 1 minus x squared d2y dx squared minus x dy dx plus m squared y is equals to 0. See, this is what we are asked to show. So let's see how we're going to go about that. The first thing is to rewrite this in y is equals to sine m. Let's write it like that to be easier for us to solve. Now we'll use the chain rule. Let u be equals to m sine arc x. So we have that. So the next thing is our y is equals to sine u. So the y, the u is equals to cos u. That has been done. Then the u, the x. I'm going to take derivative of this. So it will give me m 1 minus x squared. So that's the derivative of that. So take note of that. Derivative of this is equals to this. So I've done, or you can write it like this. I just want you to get m sine arc x. So we now have our dy dx. This is equal to dy du dx. So what would that give us? That would give us sine u. To give me cos u times this man. So my final answer will be equals to m cos u over 1 minus x squared. So I can put back the value of my u, m cos, that will be m sine arc x 1 minus x squared. So let's bring this man down. So we have dy dx equals to this. So, but before we continue to take the second derivative, let me quickly do something that will help us, so that when we take second derivative, it will not look like I don't understand what the kind of thing I'm trying to obtain. So let's find dx of now. If you look at this, 1 minus x squared is the same thing as 1 minus x all to the power of half. So if I have to find the derivative of that, 1 minus x all squared is the same thing as 1 minus x squared. So this is squared, sorry, this is squared here. This to the power of half. So we have this. This would be, if you follow the chain rule method, what you need to do, this is raised to the power of negative, there's no minus here. So what you just need to do, the first place where you let this half come down, 1 over 2, 1 minus x squared, then half minus 1. Now we now take the derivative of what is inside this bracket. Take away the derivative of what is inside this bracket. This will give you minus 2x. So our d 1 minus x squared. So by the time you do that, this will give you these two, the half, these two we cancel these two. So what we have by the end of the day, we have minus x root 1, okay, 1 minus x squared is the power of minus half. So we can rewrite this as minus x over 1 minus x squared is the power of half. You can now rewrite this in this way. You can write it as minus x root 1 minus x squared. You can rewrite this as that. This you can say that this man, you can now say that this is what we have for that. So you can also, okay, so let's so before we also continue, I also want us to work on this man, work on this, work on this. So let me imagine we are given, we also find the derivative of that. So d dx. So for this one, it's still the same. Can try and use this same method I use. So follow the same method that I use to solve. Just apply the chain rule method that I applied here. So to solve this. So I'm not going to go over that. I want you to try that on your own. So let's go back. Let's now find the. We're now going to take the derivative the second time. So we need to get this man. So I can say d so it will be derivative of this man. So I'm going to start the process. Now in this case, you have to do the derivative to. I'm going to use the chain rule, the quotient rule, because we have division here. So we're going to use the quotient rule. So see how I will do that. I'm going to apply the quotient rule. I'm going to take them one by one now. So in this case now, this man comes first. So dx. Then I have to differentiate this. Minus, I will have to keep this man constant, and no, sorry, I will have to keep this man constant, and take the derivative of that, then everything. So we have this. This is what I'm going to start the differentiation equals. So I'm keeping this man constant. I need to tamper with it. So it's this one that will now what you normally do is just the simple trick is differentiate this. Leave this one as it is. Don't tamper with. Leave this man. Just differentiate m cos and leave this one as intact as it is. So this will give you minus m sine. So we now have m sine arc x. So we have that. So then let me put dot here. So now the second one now is to what is here, this man. Just like when we are working for this. So if you differentiate this, it will give you differentiate m sine arc. That will give you m root 1 minus x squared. So that's what you get for that. So we are through with this side, with differentiation of that side. So we come here now. I'm going to keep this man constant. It's a constant. Then we differentiate. We already found the derivative of this, which is this. So I'm going to bring it here. Sorry. So let me just copy. Let me just copy it, and then I'm bringing it down here. And it's quite big, so I want to make it small. So I have minus x root 1 minus x squared. So let me delete this. So and I'll have this man. By the time you open up this square root, we remove, we go away. So we have 1 minus x squared for that. So 2y the x squared. So by the time we open up this bracket, this man and this man will cancel out. So you have what you have on this side is minus m squared sine bracket m sine x for that. This man will cancel this. So that has been done. So on this side, minus times minus, so you have plus there. So this change is changed to plus. So we now have x all over 1 minus x squared. Then I'm going to bring this man as it is and bring it here. So take note of that. So I will now have this. So let's change it to become the whole, so that the fractions will go down. So when this side now, by the time you do for this side, you have minus m squared 1 minus x squared. So I will have to copy this and bring it here. For this other side, I will just add this. This man, okay. So I will now have, on this denominator, I will have root 1 minus x squared, and then 1 minus x squared on that side. So I move to the 2y, the x squared equals to, so I can copy this, and then I will have 1 minus x squared in bracket 1 minus x whole squared. So I'm going to leave this as this. You see the reason why I leave it. I don't want to expand it. So let's leave it like this. So this is our d2y dx squared. These are the 2y dx squared. So the next thing, they ask us to prove, ask us to do some of the proofs. So I'm going to pause it here. So I've copied out all the values we need. This is what we are asked to prove. We have to prove that to show that this value here will be equal to 0. We are given that y is equal to this. We are getting our dy dx. We are getting our d2y dx squared from this. From the first one that we did, I've gotten my y. This is my dy dx, and I've gotten my d2y dx squared. So I've gotten all the values I need. So I want to put them back because this is what we are asked to show. So I want to start that proof right now. So that's the proof we want to start now. So let's start the proof. So what I will need to do is to copy this, paste it here. So the 2y, which is this, I'll copy that. I need to remove this and open the bracket, copy that. So that's the first one. Then my dy dx, I need to remove this, and my dy dx is this. So I'll copy that also. This is my dy dx. I'll paste it here. Then my y is giving us this. So I'm going to copy that. So this y, let me change it to be sine m sine arc x. So I'm going to copy this and paste it in the place of y. So let's start let's start the process. Let me increase this to 150. 150. So you can see it. So now we have this. So if you look at this man, we cancel this. It will cancel that one out. So what we have here is something of this nature. So I'm going to remove this. I won't need it. And this man Okay, on this side, we have minus mx cos m sine arc x. So we now have root 1 minus x squared. So for this, I'll just bring it down, plus. So we're almost through. Now let's find the LCM, turn everything to a single fraction. So for that, you have the denominator will just be 1 minus x squared. So this man will be copied as it is. Then this one will be minus, I'll just copy this, minus mx cos m sine x. So then plus m squared 1 minus x squared sine m sine x. So now, if we look at it very well now, we have this man, m squared, this and this is the same thing that we have here. So this one eliminates themselves. It goes away. So I can cancel that out. So this cancels out. It cancels this man out. It cancels that one out. So, and if you look at this, mx and this, they are the same. Though the x is here, but this is plus and this is minus. So this man, let me use the opposites for that. And this man, they cancel out. So at the end of the day, you are getting something of this nature. 0 over 1 minus x squared. So this is what we are getting. So invariably, it means it's equals to 0. Invariably, this man, we have been able to show that. Therefore, we have been able to show that 1 minus x squared, d2y dx squared minus x into dy dx plus m squared y is equals to 0. So this is how to go about the proof. So this is the whole solution. This is, on the first page, we got our dy dx, which is on this first page. And then we got the proof that we are asked to show, is what I did on this second page. So I hope you're able to get something from this proof. Hope you gain something. So if you can, I will advise you to watch it over and over again. Pick your pen and write, so that you can really get what this solution is all about. So thank you for watching. If you have not subscribed to this channel, kindly subscribe to this channel. Click the notification bell so that each time I publish a new video, you'll be notified. So see you again in another video. Thank you for watching.